Woke up strolling across the sea, waiting for the western sunrise. With each wave I find more peace. Let the water break upon me.
Hi, would you learn to learn about the mole? Yeah.
What do you want?
It's me again. Would you like to learn about the mole?
Okay, sorry, I must have been a little rude before. Come on in.
Thank you, sir. Hey kiddo, you want to learn about Avogadro's number?
Avocado?
No, silly. Avogadro.
Oh, what's that?
Well, it's 6.02 times 10 to the 23rd molecules.
Neato. All that stuff about the mole is neat and all, but I don't really know how to relate it.
Well, listen here, kiddo. See this bottle of water?
I sure do.
Well, it's a 32 fluid ounce bottle. I'll show you how to convert it to moles and particles.
I'm excited.
32 ounces of water. Alright, so there are 28.35 grams in an ounce. Cross these out. Multiply these two bad boys. And we get 907.2 grams of water.
Neat.
Now you may be asking yourself, how do we get that to moles?
I sure am.
Well, if we multiply 907.2 grams to 1 mole over the atomic something of what? So to find the atomic mass, we want to go to the periodic table of elements. For H2O, we need to go to H and find the atomic mass, which for hydrogen is 101. Okay.
1.01, right, mister?
Of course, how could I forget? For oxygen, it's 16 even. It's just 16. Now, since there's 2 hydrogen molecules, you multiply 1.01 by 2, and then you add that to 16 to end up with a whopping 18.02. Isn't that crazy?
It is pretty nuts.
Which is 18.02 grams. Do the math on this puppy. 907.2 divided by 18.02 equals 50.34 moles. With sig figs, it just ends up being 50 moles of H2O.
Wow, that's cool, mister.
Now going to moles to particles is a little tricky. First we take 50 moles of H2O, okay?
Sounds great.
And we multiply it by 6.02 times 10 to the 23rd particles. All over 1 mole. You see, little boy, 6.02 times 10 to the 23rd particles is the amount of particles in 1 mole. Isn't it fascinating?
Very fascinating, if I do say so myself.
Let's put this in the calculator, shall we? This ends up as a whopping 3.01 times 10 to the 25th particles. Do you think you could drink that?
Who knows? Let's find out. Hey mister, how about you give it a try?
Sure. I've got a big mouth. So 50 moles. You want to multiply that by 2.4 liters at standard temperature pressure, or STP for short. Meaning if there were 22.4 liters of gas, there'd be a mole here. It's all equal to 1 mole. Ain't that crazy?
Wow, that is pretty nuts.
The moles cross out, leaving 50 times 22.4, which equals 1,120 liters at STP.
Wow, that is pretty wild.
The shit cry.
Well, that's all fine and dandy, mister. But why does all this stuff matter?
Well, why don't you give it a try?
Try what, mister?
Count the amount of atoms in the air right now. Go for it.
Okay. A million.
Ha, silly goose. Ain't it hard trying to count all those invisible atoms?
Yeah, it's tough.
That's what the mole is for. It helps you count atoms that you can't see.
Wow, that's really cool. Well, thank you, sir, for teaching me about the mole today.
Anytime, kiddo.
Well, you must be getting on your way.
I guess that's about right. Hey, wait. Here's an idea. How about you come home with me?
I don't know.
I have candy and a puppy.
I'm sold. Let's go.
My van is parked right over here.
Okay. Just let me tell my mom. That's okay.
No, you should just come on in. Surprise me.
Okay. One mole of paper would reach the moon and back 80 billion times. 1 mole of grains of sand would be more than all the sand in Miami Beach to do. 1 mole of blood cells would be more than all the blood cells in every human in the entire world.
1 mole of sense could pay the United States national debt 86 million times. 1 mole of inches is 1,616,434 light years, which is also across our galaxy and back 8 times. There are 3 types of moles that live underground in North America: the star-nosed mole, the hairy mole, and the regular eastern mole.